Homework 7, we've got a bit of a revision of different types of reactions here. Now, this isn't an exam style question. I mean, if we look at some of the other homeworks, they are exactly exam style questions. This question here is just about making sure your core knowledge is up to where it needs to. So it's definitely worth doing, but you're not getting an exam question like this, okay? It's just one to make sure our core knowledge from year 10 and year 11 is where it needs to be. So first off, this is year 11 work. This is about oil. We've got different processes in the oil unit. We did do a summary oil lesson, so worth having a look at that if you're not sure. But first off, cracking. Cracking that's the breaking down, isn't it? Breaking down long chain alkanes. If you remember, long chain alkanes are bad fuels. If we break them down, we create more flammable products, and they are better fuels. Better fuels equals better fuels. The other product of cracking is, of course, the alkene. Creates alkenes, and alkenes are the raw materials for making plastics. Okay, raw materials for polymerization. Raw materials for polymerization. Polymerization is making plastics. I haven't really given you enough room in that box there to write all that in. I'm not even sure you can read it as I'm writing it, but hopefully you can hear it and you can do your own homework now. Combustion, most of oil we burn. Okay, so the cracking, coming back to cracking for a moment, that's breaking a molecule up. Combustion, that's also as oxidation, as adding oxygen to the to the components of that fuel. These are all chemical reactions. Okay, so we burn to get lots and lots of heat energy out. Okay, we need heat energy. Okay, so you can fill that one in. Distillation. Now this was separating a mixture. Okay, crude oil is a mixture. Okay, it's a mess. You cannot use any of the fractions of crude oil. So crude oil is made of petrol, bitumen, diesel, lots of different fractions, and you can't put crude oil in the petrol tank of a car. It would jam it up straight away. You need to separate the mixture. Now, separating a mixture is a tidying job, and that's not a chemical reaction. That's a physical process. Okay, it needs separating. And lastly, here we've got polymerization. So let's just go through this from start to finish. The first thing you're going to do with crude oil is distill it. Okay, you'll get some petrol off that, you can burn it. You get a lot of fractions that aren't very flammable, long chains. So you crack it to make them more flammable. Part of that cracking process is creating an alkene. What do you do with that? You can polymerize it to turn it into plastics. That's the third of the stage. So that's the kind of order of it. Definitely another chemical reaction. Polymerization is taking lots of alkenes, okay, taking lots of alkenes. And we did this in year 10, we didn't do it in year 11. Taking lots of alkenes and joining them together. Okay, why? To make plastic. To make a polymer. Plastic is a polymer. Okay, so that's just a bit of a revision of oil. Next, kerosene, important product. How's it obtained? What's it used for? Kerosene is jet engine fuel. It's the one everybody forgets in distillation. So kerosene is a fraction of crude oil. How is it obtained? From crude oil, from distillation. So you have to distill the crude oil, okay, to get that out. So I'm helping you quite a lot on this homework if you're watching the video. All right, depending on the conditions when cracking is carried out, different products can be obtained. In one particular experiment, molecules are C12H26, so we can put that one in there straight away, can't we? Okay, and you can draw that out. You need 12 carbons. Carbon always forms 4 bonds, so surrounding all those carbons are lots of hydrogens. Okay, now everything in crude oil is an alkane. Okay, alkanes come from crude oil. Okay, All right. Now, other products of cracking are alkenes. Now, so 3 carbons. Now, if you're double award science, you don't need to know that. It's going to be propene. If you're double award science, you don't need to know this one. This one's ethene. If you are a triple award, you do need to know those names. Okay, so C3H6, 3 carbons. If it's an alkene, it has a carbon-to-carbon double bond. I'll put it there. Now, carbon only forms 4 bonds. When you're drawing the bonds around this one now, you need to finish this one off, by the way. You need to finish the top one off. When you're drawing the bonds around this one now, you need to count the number of bonds around each carbon. This carbon's got 1 bond, so it has 3 more. Carbon always forms 4 bonds. And you can put hydrogen on those. This carbon in the middle, count the bonds. 1, 2, 3. How many more does it need to get up to 4? 1 more. Put a hydrogen on it. This carbon on the end has got 2 bonds. It needs 2 more, and you can put hydrogen on those. So you can finish that off now. You need to put hydrogen on all the empty bonds. I haven't put the bonds around that carbon. You need to do it. It's got 2 already. It needs 2 more. Ethene now. Ethene's got 2 carbons. It's an alkene, so it has a double bond. And again, put the extra bonds on these carbons and then add hydrogen around the outside. That's an alkene as well. There are 2 homologous series in the previous table. Okay, there's alkanes and alkenes. Okay. Fully explain the differences between them. Well, alkanes have carbon-to-carbon single bonds. They're saturated. Alkenes have a carbon-to-carbon double bond. They are unsaturated. The difference is the carbon-to-carbon double bond in the alkene. The double bond is a reactive site. So the alkene group, the alkene homologous series, is a little bit more reactive than the alkane homologous series. Including your answer where they're obtained. So alkanes are from crude oil. Alkenes are from cracking. Differences in the chemistry and a suitable test to distinguish between them. This is single chemistry only. The test between them is bromine water. Okay, you add bromine water to an alkene. Okay, it turns colourless or decolorizes. Do not say goes clear. If you add bromine water to an alkane, it stays orange. Right, so again, you can have a go at that. Write a balanced symbol equation for the complete combustion of methane. Well, methane is CH4. Okay, if it's going to combust completely, it reacts with oxygen, O2, okay, and it makes carbon dioxide and water. The products of complete combustion are carbon dioxide and water. You need to learn that. Okay, so I'll have the products there, please, and then you can balance it. Explain the difference between complete and incomplete combustion, including your answer to the conditions that determine the combustion type and the differing products. Right, so complete combustion, we've already said. Okay, this happens when there's lots of oxygen, complete combustion. Okay, lots of oxygen. And a really very flammable hydrocarbon. Lots of oxygen, okay, and a flammable hydrocarbon. And you get complete combustion then. The products are CO2 and H2O. Products, CO2 and H2O. Needs learning, learn that, gets tested all the time. Incomplete combustion, okay, is the opposite. Okay, if you do not have enough oxygen, okay, incomplete combustion, so not enough oxygen. Now the products of these ones, there's a number of products, but the 2 you need to know about, one is carbon in the form of solid carbon, it's called soot, so soot, and the other one is carbon monoxide. Form of that is CO. So complete combustion, carbon with lots of oxygen, CO2, that's it's stable, that's how it's happiest. When it doesn't have quite enough oxygen, you get carbon monoxide, that's a gas. And when you don't have really, you have less oxygen, you get carbon on its own, and that's soot. Okay? One of these products of incomplete combustion is known as the silent killer, that's carbon monoxide. Including your answer the type of appliance that produces it. Well, faulty gas appliances. Okay, so where methane is burnt and there's not enough oxygen getting to the flame, and they are faulty if they are producing carbon monoxide. Why is it known as silent, and how is it killed? So it's silent because it's colourless and odourless. So you can't see it and you can't taste it. You don't know you're breathing it in. You breathe in, you think it's just oxygen and nitrogen and the normal components of the air. Okay, how it kills. It binds to the hemoglobin. Hemoglobin, red blood cells carry oxygen and carbon dioxide around the body normally. Okay, so you breathe oxygen in, it binds to hemoglobin. Your hemoglobin takes it to the cells in your body that needs it, where it's given to the cells and it's exchanged for carbon dioxide. Carbon dioxide is taken back to the lungs, you breathe it out. Okay, so there's a constant transfer of oxygen and carbon dioxide and hemoglobin. Carbon monoxide binds to that hemoglobin and doesn't let go, which means there's no way for oxygen and carbon dioxide to travel around the bloodstream. Okay, that's how it kills, and you need to know that for your GCSE.